So in this video, I'm going to show you how to make a table of descriptive statistics. And so, descriptive statistics, so this would be the sort of summary statistics, sometimes they're called. So this would be basic information about your variables, such as frequency, measures of central tendency, like means, for instance, measures of spread like standard deviation and range and things like that. And oftentimes this is one of the first things that you do when you're embarking on some sort of a research project is getting to know your data by looking at the descriptives. So let's say that to start off, what we want to do is we want to make a table of descriptives that summarizes the, say, demographics of the students who are in our data set. And so in this case, the data set that we have loaded is student level. So each line in the data set represents a different student. So we have 23,503 students in our data set. And let's say that we want to let's pick some variables. So let's say that we want to look at the characteristics of our sample based on sex or gender, based on race, and based on, let's say in addition to demographics, let's say we want to look at math scores. So in this data set, we have information about the student's sex or gender, their race, ethnicity, and we also have information about a math assessment that they were administered. So before we get started, we want to make sure that we know how our variables are measured, because this becomes really important to making a table that's actually useful that we can use to answer the questions that we might have. So the first thing to do is just if you don't know your data very well, you can start by just using the codebook command. Or if you have a technical manual that goes along with your data set or a user's manual or something like that, definitely consult that for information on how this data was collected and recorded and so forth. Because by default, this isn't what I'm showing you here using the codebook command isn't going to be in every data set by default. So this data set just happens to have more information. So we'll start with this variable x1 sex. So this is coded as, 1 corresponds to male, 2 corresponds to female, and if it's missing, meaning that the people who collected the data didn't get a response about the student's sex or gender, that's coded as a 5. Looking down here, x1 race is the variable that captures students' race, ethnicity. So this would be, if a student is American, Indian, or Alaskan Native, they're coded as 2. If a student is white, they're coded as 9. If a student is Black or African American, they're coded as 4. Going on down to the math score. So this, we can see, because this looks different here than up here for the race variable. So this is a continuous variable because it's telling us about, the range, it's telling us about how many unique values there are, the mean, standard deviation, and then percentiles. So let's say that, this can all tell us, important things. But let's say we want to put this into, one table that makes it a little bit easier to look at once. So we'll start here. Same variables, and so instead of using the codebook command to see how these variables are entered, what I'm going to do is just use the summarize command. And so what I'm going to show you first is doing it wrong. So that, as you can see, that the code ran, and so we've got means and standard deviations and ranges right here, but some of these don't actually mean anything. In the case of math, we do have a mean that probably means something because this is a continuous variable. Although I would want to check and see what this -8 means, because this could be an outlier, or this could mean that you need to go do something, some sort of recoding or sort of data management kind of tasks here to see what this is. But in the case of sex and race, we already know that these are categorical variables. And so let's say race, for instance, the mean is 7.38. So if you took that very literally, that would mean that on average, the students in your data are more than one race, but not Hispanic. A little bit more racial than that, I guess. And as you're listening to me say that, you can tell that I'm sort of hesitating because that doesn't really actually mean anything. That's not an actual, like an honest or reasonable representation of the information in this particular variable. And the reason for that is because this is a categorical variable, this race variable. It's categorical, and so therefore an average race doesn't actually mean anything, right? Because a student, so if we were to look here, white students are coded as 9, Asian students are coded as 3. That doesn't mean that white students are 3 times as sort of racial or whatever as Asian students, right? This is just they're in alphabetical order, that's it. And so because of that, they're purely categorical, they're not ordinal, just categorical, and so Stata can compute a mean of them. We just wouldn't want to actually use that mean to do anything with. So I'm kind of like, as you can see, I'm spending a lot of time here because this is a really easy mistake to make. And this is why it's really important to keep in mind what you know about your data and make sure that you know what you need to know about your data and to make sure that you draw on that to inform what you're asking Stata to do, because Stata will kind of, as you can see, Stata will run something that doesn't make any sense. So now let's see, how should we construct this? So since we know that 2 of these variables, sex and race, are categorical in nature, we can just specify to Stata using I dot in front of it, so no space, just I dot variable for sex, and then I dot the variable for race. And that tells Stata that these are categorical variables, and so we want to make our descriptives table look different. So now what we can see is, so for the first variable, x1 sex, it breaks it out by male, female, and missing, the 3 categories. Then for x1 race, it breaks it out by the 2, 5, 7, 9 different categories within that variable. And so let's see how to make sure that we would interpret all of this correctly. So for the n, the number of observations, this refers to the number of observations for the variable x1 sex, so 23,503. That doesn't mean that so you wouldn't want to say there's 23,503 males and 23,503 females. There are 23,503 observations in the data set, which means every observation in the data set, as you can see over here. And so then we can go over to the next column, which shows the mean. So in this case, what mean represents is the proportion for each category. And you can convert that into a percentage. So a proportion of 0.509, we can convert that into a percentage and round it up and say 51%. So 51% of the students in our sample are male. 49%, or just barely over 49% of the students in our sample are female. And a very small number, so 0.03% approximately, the students in our sample, they didn't provide information about their sex. Same thing if we go down to race. So convert these proportions into a percentage. So this 0.7% of the students in our sample are American Indian or Alaskan Native. About 14.4%, let's round, 14.4% of the students in our sample are Hispanic, no race specified, which corresponds to this right here. Then, about 0.5% of the students in our sample are Native Hawaiian or other Pacific Islander, which is right here. So that is how we get a different descriptives table that we can use to make more sense of the data set that we've got here. And then lastly, the X1 math score, which we didn't actually change, right? Because we said, well, this is continuous. So this gives us, on average, this is the math score. This is the standard deviation of that math score and the numerical range of that math score. So that is how we can make a table of descriptive characteristics or descriptive statistics, or summary statistics, as they're sometimes called. And in doing that, just making sure that we draw on what we know about, making sure we know about our data set, and that we draw on what we know about our data set to make a table that is actually informative. Because again, this mean race of 7.387 doesn't actually say anything about the race of the students in our sample. Compare that interpretation, which doesn't really mean anything if you think it through, and go down here and say, okay, well, about a little over half of the students in our sample are white. About 14%, a little over 14% of our students are Hispanic, no race specified. About a little over 10% of the students in our sample are Black or African American. That actually says something about our sample versus an average race of 7.38, which does not. So again, just be very thoughtful in what you're asking the software to do. And as long as you do that, you're going to get some results that are going to be useful for you getting to know your data and to be able to answer some descriptive questions about that data.